Hi, I'm Burak Demirel. I recently defended my doctoral thesis on architectures and performance analysis of wireless control systems with the Department of Automatic Control at KTH Royal Institute of Technology, Stockholm. Modern industrial control systems use a multitude of geographically distributed sensors and actuators to continuously monitor and control physical processes. Information exchange among control system components is traditionally done through physical wires. The need to physical wire sensors and actuators limits flexibility, scalability, and reliability. Since the cabling cost is high, cable connectors are prone to wear and tear, and connector failures can be hard to isolate. By replacing cables with wireless communication networks, it is possible to obtain a more cost-efficient and reliable system. The use of wireless networks in feedback loops creates a lot of advantages, but also introduces new challenges. In addition to model uncertainties, disturbances, and noises that can be experienced in traditional control loops. Network imperfections, such as information losses, delays, or data rate limitations, pose a further limit on how well we can control a system and influence the way we should control a system. It is necessary to resolve these issues to fully exploit the benefits of wireless control systems. One approach could be to provide rescheduling policies to improve the reliability and end-to-end latency. Another approach could be to design control algorithms that are able to handle the communication imperfections. But by jointly designing communication policies and control algorithms, we might obtain a better performance. In this thesis, we looked for answers of several questions. Is it beneficial to jointly design control algorithms and networking protocols? Or can a modular design achieve the optimal control performance? How can we characterize the trade-off between the control and communication and optimally choose parameters such as sampling rate? Can we improve the control performance by retransmitting dropped packets on a lossy network? Or does the additional retransmission delay deteriorate the performance? Can we get significant performance benefits by choosing different control architectures? Can we design a control algorithm and event-based policy that optimally trades off communication cost and control performance? The solutions we proposed for these questions can give us a better understanding of performance trade-offs in wireless control systems. The knowledge that we gained can be useful to design the future industrial control systems. If you're interested in my research, I would like us to discuss this in more detail. Please get in touch with me. Thank you for listening.